Imagine you see someone for the first time, and suddenly your heart starts racing, your palms get sweaty, and your mind can't stop thinking about them. Feels magical, right? But what if I told you that this magic is actually chemistry, real brain chemistry? In this videocast, we're going to dive into what really happens inside your brain when you fall in love. How your hormones, reward system, and emotions team up to create that crazy, beautiful feeling we call love.
Okay, imagine this moment. You see someone, maybe just get a text from them, and boom, everything else just fades out. Your heart's pounding, you can't focus, and suddenly it's 3 a.m. and you're just replaying some tiny interaction over and over.
Yeah, that feeling, that intense, almost dizzying sensation. It's not just, feelings. It's pure biology taking the wheel.
All right.
And that's what we're diving into today, how falling in love is this powerful cascade. It's chemistry, it's changes in your brain structure, neural activity.
So we're basically looking at the brain as a chemical factory.
Exactly, a high-stakes chemical factory. We want to show you the levers, what drives that desire, the obsession, and then hopefully that long-term connection.
Okay, so let's try and map that out. We're using a framework here from biological anthropologist Helen Fisher. She breaks down this huge experience into 3 stages, right?
Correct. 3 distinct components, scientifically speaking. First up is lust. That's the basic physical drive, hormones like testosterone, estrogen. Pretty straightforward. Second is attraction. This is the big one early on, the high, where that one person becomes, everything. The obsession really peaks here.
And the third?
That's attachment. This is the long game. The deep bond, that feeling of safety, calm, security with someone.
Okay, so lust, attraction, attachment. And the key thing seems to be that attraction is like the explosion at the start.
Yeah, the fireworks.
But it's attachment that needs to kick in for it to last, to become something stable. Like you need the marathon after the sprint.
Perfectly put. The sprint gets you there. The marathon keeps you going.
All right, let's dig into that sprint then. That head over heels initial phase. Someone catches your eye. What's the main chemical making you feel that urgent buzz?
That is pure dopamine. And it's not just about pleasure, really. It's the motivation chemical.
Motivation. How so?
Well, dopamine gets released whenever your brain anticipates or gets a reward, something that feels good. And crucially, it makes you want to seek out that reward again and again.
So just thinking about the person or seeing their name pop up gives you that little hit of joy.
Exactly. But here's where it gets really interesting. When dopamine surges like this, in the context of attraction, it does more than just feel good. It actually suppresses other parts of your brain.
Which parts?
Specifically, it tends to quiet down the prefrontal cortex.
Okay, and that's the part responsible for?
Critical thinking, judgment, assessing negatives. So when that area goes quiet, suddenly that person seems flawless, perfect, like they can do no wrong.
Wow, so you're biologically wired to ignore the red flags, basically?
In a way, yes. Your brain is pushing you to focus only on the reward, pushing the critical analysis aside, at least temporarily.
Okay, so dopamine handles the, wow, they're amazing part. But what about the obsession? The feeling like you literally cannot stop thinking about them. That feels different.
Ah, yes. That's the beautiful or maybe maddening imbalance of serotonin. While your dopamine is shooting up, your serotonin levels actually drop significantly at the start of love.
And why does a drop in serotonin matter? What does serotonin usually do?
Serotonin helps regulate your mood, keeps things stable, calm, grounded. So when it plummets, your brain state starts to look a bit like, conditions involving obsessive thoughts. Think OCD.
Seriously, like clinical OCD.
The pattern is similar. That sudden drop is linked to why you can become so preoccupied. You're not just choosing to think about them. There's a chemical compulsion driving you to fixate on every little detail, every text, every possible future scenario. That craving, that mental loop, that's tied directly to the serotonin dip.
Comparing it to OCD definitely gives early love a much more intense, almost scary layer. Okay, so we got dopamine making them look perfect, serotonin dropping, causing obsession. What about the physical stuff? The racing heart, the sweaty palms.
That's cortisol reporting for duty.
The stress hormone.
Exactly. Because early love, let's be honest, is stressful. It's high stakes. So cortisol ramps up, causing those physical symptoms we talked about, the fast heart rate, maybe feeling warm, butterflies in your stomach.
So it's that weird mix of feeling nervous but also really excited?
Precisely. It's your body on high alert, recognizing that you're pursuing something major, a potentially huge biological reward.
Okay, this whole chemical storm,
Rare.
we see it play out in that story of Ollie and Nazanin, right?
Yes, it's a great illustration. Ollie sees Nazanin, dopamine surges, quieting his critical judgment. She seems amazing. Serotonin drops, locking him into those obsessive thoughts about her.
And the cortisol kicks in.
And gives him that racing heart, that physical jolt that tells him unmistakably his entire focus has just shifted onto her. It's a complete takeover.
Okay, so once that initial high-intensity attraction phase starts to, let's say, stabilize a bit, the brain does this really clever shift. It moves away from just chasing that reward and starts prioritizing long-term stuff. Bonding, trust, safety.
Right, moving into that attachment phase we mentioned.
Exactly. This is where a new chemical team sort of takes the lead.
And the first one is probably the most famous one for connection. Oxytocin.
That's the one, often called the cuddle hormone or hug hormone.
Because it's released through physical closeness. Holding hands, hugging, kissing, intimacy, all those things trigger oxytocin release. And its job chemically is to reduce stress and anxiety.
Oh, okay.
It floods your system with feelings of calm, deep closeness, and that sense of shared safety, like you can finally relax around this person.
So it kind of replaces that cortisol-driven anxiety from the first stage, swaps nervousness for comfort.
That's a great way to think about it. It dials down the stress and dials up the security. And working right alongside oxytocin, you have vasopressin.
Vasopressin, okay. What's its role?
Vasopressin is strongly linked to long-term commitment. And interestingly, maintaining monogamy, especially noted in animal studies, though relevant for humans too, it helps form those stable, pair-bonded relationships.
Okay, so if oxytocin is about the warm, fuzzy connection and comfort, vasopressin is more like the glue, promoting loyalty, stability over the long haul.
Yes, that's a good analogy. It helps build that deep, enduring trust you feel with a partner. It helps make the relationship feel like a secure base, instead of a source of constant drama or uncertainty.
Makes sense. Now, something else that came up in the sources was that the brain's reward system doesn't just switch off when attachment takes over. It changes its focus.
Exactly right. The core motivation and reward centers, areas like the ventral tegmental area, the VTA, and the nucleus accumbens, they stay active. They're still part of the picture.
But they're not driving that frantic search for the initial high anymore.
Right. They transition. They're still giving you a sense of reward, but it shifts from the volatile excitement of early attraction to the more profound, stable joy you get from deep emotional closeness and security. The reward becomes the connection itself, not just the chase.
And this is where that link to parental love comes in, which is fascinating.
It really is. The research shows that both romantic love, especially in the attachment phase, and parental love activate similar reward pathways in the brain.
So looking at your long-term partner can light up some of the same foundational circuits as looking at your child.
Pretty much. It suggests that our capacity for long-term romantic love might be deeply rooted in, or at least shares pathways with, our species' fundamental mechanisms for bonding and caregiving. It's all about connection.
That connection between romantic and parental love circuits is, pretty profound. Let's shift gears a bit now to some of the more surprising, maybe hidden facts about how love works and how modern life might be messing with it.
Okay.
The first one is probably the most attention-grabbing. Early love acts like a natural addiction.
It genuinely does, neurochemically speaking. The brain areas that light up so intensely during that initial attraction phase, they're the same circuits that are activated by addictive drugs like cocaine or highly rewarding behaviors like gambling.
Wow.
You're essentially chasing that intense dopamine high, and your focus narrows entirely onto the object, or in this case, the person providing that reward.
Okay, but that sounds problematic. If it acts like an addiction, how is healthy love different from, say, a substance dependency? There has to be a difference.
There is, and it's crucial. Generally, clinical addictions tend to worsen over time. You need more of the substance, the negative consequences pile up, functioning gets impaired.
Right.
Healthy love, assuming it makes that successful transition into the attachment phase, actually does the opposite. It matures, it softens. The intense compulsion lessens, and it's replaced by feelings of security and warmth. The VTA, that reward area, learns to value the steady comfort of connection, not just the roller coaster of uncertainty.
So the trajectory is key. Love ideally mellows, addiction escalates.
Got it.
Okay, another interesting comparison that came up was from physics, comparing love's changes to a phase transition.
Yeah, like in thermodynamics. Think about water turning into steam or iron changing its crystal structure when heated. It's not just one thing changing, the whole system reorganizes.
So the idea is that the shift from intense attraction to stable attachment isn't just a feeling changing. It's like the brain's whole operating system for that relationship shifts into a new, more stable configuration.
Exactly. It's a fundamental change in the emotional and neurochemical state, a shift to a new, more ordered equilibrium. It's not just turning a dial. It's like the whole machine settles into a different mode.
It's a cool way to think about it.
Yeah.
Now, something really relevant for, well, now, how modern life might be interfering with this whole delicate chemical dance.
Oh, definitely. This is important. Things like chronic stress, not getting enough sleep, poor diet, even just too much screen time. These aren't just minor lifestyle factors. They can directly mess with the brain chemistry we need for healthy love.
How so? Give me an example.
Okay, take chronic stress. It keeps your cortisol levels high, right? Keeps you in that fight or flight, high alert state. Well, if you're constantly stressed, it's really hard for your brain to make that crucial shift into the calm, secure, oxytocin and vasopressin-driven attachment phase. Your system is basically stuck in stage 1 mode.
So if your baseline chemicals are already out of whack from modern life, it might be genuinely harder to settle into that stable, long-term love state. Harder to commit, maybe.
It could absolutely impact that ability. You can't easily build a secure attachment if your body feels like it's constantly under threat.
That makes a worrying amount of sense. Okay, one last fascinating point from the sources. The difference in brain activation when loving humans versus animals or nature.
Yeah, this was interesting. While loving a person strongly activates those complex social cognition areas of the brain, because, human relationships are complicated,
Right.
the analysis noted that sometimes the connection felt towards, say, a pet or the feeling of awe in nature can light up the pure reward centers even more strongly, or perhaps more simply.
More strongly, why would that be?
Well, the thinking is that human connection, while incredibly rewarding, also comes with a lot of social calculation, potential judgment, complexity. Loving a dog or looking at a beautiful landscape, it's rewarding, but maybe less complex. It might trigger those basic, straightforward reward circuits more directly without all the social processing overhead.
Huh. So simpler reward, cleaner signal, in a way. Interesting hashtag tag outro. And
So if we boil it all down, let's quickly recap that chemical map for everyone listening. You've got dopamine driving the initial focus, the excitement, and kind of shutting down that critical judgment.
making them seem perfect.
Right. Then the big serotonin drop creates that intensity, the obsessive thinking, the can't get them out of your head feeling.
The slightly crazy part.
Maybe a little. Then, as things hopefully progress, oxytocin comes in to deliver the bonding, the trust, the closeness.
And comfort and safety.
And vasopressin helps lock it in, encouraging loyalty and that long-term stability.
So love kicks off, feeling almost like an addiction, obsessive compulsive reward system totally dialed up.
Yeah.
I think Ollie's seeing Nazin in that intense moment.
Absolutely. High overdrive.
And then ideally it evolves. It shifts into something calmer, more secure, deeply satisfying as attachment takes over and those bonding chemicals become dominant.
It's really this complex, fascinating, sometimes messy mix of neurochemistry, powerful emotions, and deep motivation. It just shows how our most profound human experiences are really rooted in these biological drivers, They grab our attention and fundamentally reshape how we see the world.
It definitely makes you think, if we can map love out like this, break it down into chemicals and brain pathways, how much of what feels like choice, like falling in love, is really just us experiencing and narrating this unavoidable neurochemical cascade?
A provocative thought to leave people with.
Indeed. Something to ponder the next time your own heart starts doing that funny little race.
Love isn't just about butterflies in your stomach or romantic songs on repeat. It's your brain, your chemistry, and your hormones working together to make you feel connected, excited, and sometimes completely out of control. So next time you fall in love, remember, it's not just your heart. It's science doing its job beautifully. Thanks for watching this videocast. And hey, if you enjoyed exploring the science of love, don't forget to hit that subscribe button so you won't miss the next one.